Welcome to the Project Management Prepcast, helping you prepare for the PMP exam. Here's your instructor, Cornelius Fichtner.
Hello and welcome back to part 2 of our lesson here on Estimate Activity Durations. I'm your instructor, Cornelius Fichtner. So, in part 1 we looked at the overview and inputs. And now in part 2 we're going to look at the outputs, the review at the end, but of course first we're going to start with the tools and techniques. There are 6 tools and techniques that are ahead of us. They are expert judgment, analogous, parametric, and 3-point estimating. We also have the group decision-making techniques, and we have the reserve analysis. We'll look at each of these 6 in detail. Our first tool and technique, expert judgment, means, of course, ask the experts. Let's repeat what I said in the opening of part 1. The experts are supposed to estimate the durations of our tasks, so it's not surprising that expert judgment is our first tool and technique in this process. And there are a couple of reasons for this. First of all, many projects are complex and require the cooperation of many disciplines and require a variety of experts. Nobody can have all the experience. You as the project manager cannot have the necessary experience to estimate everything. You may have a certain expertise and you should give your input in those areas. But how much do you know about underwater welding? Not much, I guess, right? Well then, let the experts help you. Second, experts have years of experience in their specialty. Experts can fall back on their know-how, experience, and also their instinct or gut feeling. As an example, an uncle of mine in Switzerland is an experienced architect. He told me the story about when they had to estimate the size of a building. He made a guess about the square meters, and later on it turned out that he had been within 5%. This is what 40 years of experience as an architect will give you. Next on the list of tools and techniques are the different estimation techniques. And do note that project time management uses some of the same techniques that we use also in project cost management. And first, there is analogous estimating, which uses values from a previous project as the basis for estimating the same parameters for the current project. We have parametric estimating, which uses statistical relationships between relevant historical data and other variables to predict cost estimates and time estimates for our current project. And we also have 3-point estimating, which uses the most likely, most optimistic, and most pessimistic effort to approximate a duration. Please do pay attention here, because these 3 techniques will be very similar when you go through them in a future lesson on estimate costs. Analogous estimating, according to the PMBOK guide, is defined as a technique for estimating the duration or cost of an activity or a project using historical data from a similar activity or project. And similar activity or project are of course highlighted because you cannot compare oranges to apples. The project from the past that you use as an analogy to estimate your current project, or of course also activity, has to be as similar as possible. If there are big differences between the two, well, your estimations are going to be based on the wrong data. But let's take a look at what this really means. Let's take a look at this picture here, where we have 2 doors and houses which are different but similar. If you had to work on the blue door and then you had to do similar work on the green door later on, well, it seems reasonable to use similar duration estimates. This is how analogous estimating works. It means that you use the actual time from a previous similar project as the basis for estimating the time frame for the current project. Analogous estimating is used when little information is known about the current project, or when 2 projects appear similar. Of course, if they appear similar but in fact they are not similar, then the estimate will be inaccurate. So for painting the doors, you would expect it would take roughly the same amount of time to work the green and the blue door. But what if the two houses were hooked up to two very different alarm systems, and then they had issues with the alarm system at the door? Well, troubleshooting and fixing that issue may be radically different from one house to the other. Analogous estimating is beneficial in that it is not time-consuming and doesn't cost much because it can be done very quickly. Well, it took us 3 hours to paint the blue door. It'll take us 3 hours to paint the green door. There you go. That was a quick analogy. Analogous estimating is good for ballpark figures. It's a gross figure, but be warned of its downside. Namely, it's not very well suited for accurate estimations of a project timeline development. As another example here, one of my lead software developers told me once, after we had the first meeting with a customer, that he thinks that, well, the project that we have here is going to take about 3 months of pure development because it's similar to the one that I've pretty much just finished. And he was right. He was dead on, because we were done after 11 weeks of pure software development. We are moving on to parametric estimating, which, according to the PMBOK guide, is an estimating technique in which an algorithm is used to calculate cost or duration based on historical data and project parameters. By algorithm, we mean we are using a mathematical formula that represents a statistical relationship between historical data and a parameter or a variable. For example, if you were to be laying bricks and you know that historically you can lay 10 bricks per hour, and if you know that you had 200 bricks to lay, you can approximate that you would need 20 hours to complete the activity. Parameters could be duration, budget, site, weight, complexity, you name it. Now let's take a look at what this really means again. Parametric estimating can vary widely. It's more accurate if the following factors are in place. First of all, we have to have accurate historical data. In my 10 bricks example from just a moment ago, what if the number were wrong? What if the actual number per hour were just 8 and we just got the wrong figures there? Well, you need accurate data from the past. We also need parameters in the model that are actually quantifiable. And when we talk about actually quantifiable, we mean something like this: the total numbers of square meters multiplied by the cost per square meter. That will work quite well. But the measure lines of code in software development is a little bit more difficult to quantify. What do you multiply that with? The hourly rate of your developers, or how many lines of code they can write per hour? But software function points, those again, they may give you a higher accuracy when you're trying to use those in parametric estimating. Another factor in the accuracy of parametric estimation is that we need to have a scalable model that works on both small tasks, small projects, as well as large projects. And more sophisticated models which account for different parameters might also influence duration estimation, and they may yield more accurate estimates there. Remember that you can use parametric estimating on a specific portion of the project, a single task, or you can use it on the entire project. And so we are moving on to 3-point estimating, which the PMBOK guide defines as a technique used to estimate cost or duration by applying an average of optimistic, pessimistic, and most likely estimates when there is uncertainty with the individual activity estimates. Okay, so we understand we're taking something optimistic, pessimistic, and most likely, and we somehow calculate the average. Let's take a look at what exactly we mean by this and how we can do that. One of the key benefits of 3-point estimating is that it takes uncertainties into consideration, because often your experts would tell you, I don't really know how long it will take. 3-point estimating is also referred to as the program evaluation and review technique, better known as hurt. It makes sense in the real world that you do not really know how long a particular activity will take. Specifically talking about certain activities such as research or development. How long will it take to research something? Well, we really don't know. And if you get the, well, we really don't know how long it will take, go ahead and ask your experts 3 questions. How long will this take if you are optimistic? This is the best case scenario. Then second, ask them, how long do you think this is most likely going to take? And this is the realistic scenario. And of course, you will also ask them, how long will this take if you are really pessimistic? And this is the worst case scenario. You then have to consider all 3 numbers to get to your 3-point estimate. Project managers can use 3-point estimating to gain a greater degree of control over how the end value is calculated. There are many ways this might be done, but the 2 most common ways are through triangular or beta distribution. Let's discuss each of these in turn. In the triangular distribution, you need to find the average of 3 estimates to get to your expected duration. In other words, to calculate this, you add up your optimistic estimate, your most likely estimate, and your pessimistic estimate, and then you divide them by 3. For example, here in our pie chart, you could have 45 minutes on your optimistic estimate. Then you would have 75 minutes for your pessimistic estimate and 60 minutes for your most likely estimate. And if you take these 3 numbers and you put them into the calculation that you see there on the left, well, 45 plus 60 plus 75 divided by 3 is 60. That is your average of the estimates. You add them up, you divide them by 3. It's as simple as that. Note that the graph here represents the weight that you actually place on the estimate, not the duration of the estimate themselves. We know that the pessimistic estimate would be the longest duration, the optimistic is the shortest, while the most likely is somewhere in between. But each of these has a weight of 1/3 for us to calculate our average. Okay, so in the triangular distribution, all 3 estimates have equal weight in the average. In beta distribution, you consider a weighted average where all estimates are not weighted equally. Here you can pretend to divide your pie into 6 slices instead of just 3, and you assign the optimistic and pessimistic estimate just 1 slice each, but you would give the most likely estimate 4 slices. That gives it more weight. That is exactly what you do with the beta distribution PERT estimate. You weigh or assign more importance to the most likely estimate. To calculate this, you add up your optimistic estimate, your pessimistic estimate, and then you add 4 times your most likely estimate, and then you divide the whole thing by 6. The beta distribution gives a weighted average of 3 estimates where you will get an estimate that is much more balanced and likely to be more accurate. Interesting enough, however, in this particular calculation here, the way we selected these numbers, you will still get 60 minutes for your estimate. But that's just how the math worked out for this example here. Let's see how this works using different optimistic and pessimistic estimates on the next slide. And we're going to do this with this comparison table here. In the middle, we're going to place the numbers that we have already calculated there, where we figured out that both the triangular and the beta calculation just happened to come out to 60 days. But let us now assume that we have a really optimistic team, and they say, you know what, those 45 days, they're not really right. I actually think that it's 30 days or even 15 days, and this is what's going to happen here. So if we change the numbers in our calculation from 45 as optimistic to 30 or 15, as you can see, the triangular numbers and the beta numbers, they are starting to move away from each other. You could also see that the triangular distribution there is more affected by that lower number, whereas the duration estimates based on the beta distribution stays more closely to our most likely estimate of 60 minutes. The same is true if we had a team that was really pessimistic and said, no, those 75 as your pessimistic estimates, that's wrong. It's going to be 120 days. It's going to be 150 days. Again, we can see that duration estimates based on the beta distribution, they remain more closely to the 60 hours than which is your most likely estimate, and your triangular distribution is really going to move away from that central most likely estimate. However, now that you know this particular formula, I'd like to introduce you to another form of duration estimation, as it has been immortalized in the following project management proverb. To estimate a project, work out how long it would take one person to do it, and then multiply that by the number of people on the project. It's certainly an alternative approach of doing it, but please don't select this as an answer on your PMP exam. Group decision-making techniques are our next tool and technique that can be used at arriving at a duration estimate. You can use brainstorming, you can use the Delphi technique, or you can use the nominal group techniques to do this. Group techniques, they not only help in team dynamics, but also help build buy-in for the project amongst stakeholders. Overall, these techniques, they can lead to new and additional information, which can help this process and the project overall. It also is a way of refining and getting more accurate estimates. So now we are at the point in our process where we have all these duration estimates. What do you do now? Well, I can tell you what I would do. I would add in a reserve. I would analyze my estimates. I'd consider things as, well, who estimated this? Who is going to perform the task? How complex is the task? And so on. And based on this, I usually put in a contingency reserve, which is a time buffer or reserve either at the activity level or as an aggregate. This contingency should be clearly marked in your schedule documentation. This could be a fixed number of work periods. Maybe in your company you add fixed hours so that you will add a 2-day reserve to every task that takes 3 weeks or more. It could be a percentage of the estimate. Maybe I'll add 10% in. This reserve will either be used up during the project or it will be eliminated. It could also be an amount based on a quantitative analysis using a Monte Carlo model, which will be discussed in more detail in a future lesson on Perform Quantitative Risk Analysis. Ultimately, through the course of the project, the reserve may be used, reduced, or eliminated if it is not needed. As part of the reserve analysis, you also need to know the difference between the contingency reserve and management reserve. So let's take a look at these two in turn and elaborate on the contingency reserve first. And by the way, we'll look at this in more detail in our lessons on estimating costs and determining budgets. So the contingency reserve is also known as the time reserve buffer. It addresses the known unknowns. For example, in a software development project, a contingency reserve may be assigned to account for the rework required to fix defects in newly developed software. A contingency reserve can be assigned at the activity level, at the project level, or both. We already discussed how this can be a fixed number or a percentage of estimated durations. The contingency reserve may change and is not necessarily static. It can be removed, increased, or used up. As you go through the project, it is updated as part of the schedule baseline. That means it is part of the schedule baseline. And also, very important, the contingency reserve is owned by you. It's owned by the project manager. You decide whether we're going to use it or whether we're not going to use it. Moving on to the management reserve, it addresses the unforeseen work or the unknown unknowns. It is not part of our schedule baseline. However, depending on contract terms, if management reserves are used, it may mean updating the schedule baseline. Note that this update to the schedule baseline will likely require a proper change approval. And even though it is not part of your schedule baseline, it is, however, part of your overall schedule requirements. As the name implies, the management reserve is owned by management. And as a project manager, you would need to obtain approval before you are allowed to tap into this particular reserve. We are moving on to the outputs here in Estimate Activity Durations, and we just have two. We have the activity duration estimates and we have the project document updates. Let's take a look at both of these a little more in detail, beginning of course with the activity duration estimates, which are pretty straightforward. They are the number of work periods required to complete an activity. Activity duration estimates, they will not include any lags or time delays which need to be considered as part of the develop schedule process. We'll cover this in more detail in the corresponding lesson for that particular process. And just as you will see later in estimating cost, as there is a level of uncertainty around every single estimate, you reflect this in how you state your estimate. You should include a probability to reflect your degree of confidence or a range for your duration estimate. So you have to be careful not only in the technique of how you come up with estimates, but also in how you communicate the estimates to others. When it comes to the activity duration estimates, let me give you an example. Your boss comes to you and shows you a preliminary scope for a new project and asks, how long will this type of project take? And you look at it and you think to yourself, well, this should take about 2 months, roughly. But to your boss, you will say it's going to take about 6 to 10 weeks. This is what we call a range. You always give a range because we never ever give an estimate that is just one number. You could also have said, oh, it's going to take 2 months plus or minus 20%. And the reason why you never give a single number is this. If you tell your supervisor that this will take exactly 2 months, then there's a tendency to fixate on this single number. It is the number that he will remember and what you will be held responsible for. It doesn't even matter that this was just a first and friendly conversation over a cup of coffee. If you say 2 months, he will hear 2 months, and you will be accountable for that. Alternatively, you could state your estimate with a probability or level of confidence. You could say that there is an 80% probability that the project will take 2 months or under, or you could state that the project has a 20% chance it will take longer than 2 months, or so on. Personally, I prefer using the range. It'll take 6 to 10 weeks. I think the inner and outer limits here, they allow the mind to more easily veer away from the central number there of 2 months. And it's clear it's 6 to 10 weeks. It's not just 2 months straight on. Our second output are the project document updates. But what are we going to update? Well, you may need to update the activity attributes. We already mentioned the risk register. What are some details which you may have to document, which you may have to update? Well, you should include duration estimates for each schedule activities along with the basis for your estimates. That is what this process is all about. So you need to update that. You should also include any assumptions that were made during your estimates and doing your estimates, as well as any contingencies. So the more information about the basis of how you estimated and who estimated and why you came up with these numbers, the better for you later on. Remember what we said about doing all of the processes in project time management as one big, huge blob? The activity attributes are a good example for this. For instance, most people will use a project management scheduling software to manage their activity list. So the duration, ranges, and contingency is added into this tool. And usually when I do this, I really have a hard time not to define predecessors and successors at the same time. It's so obvious. I first have to mix the concrete, that takes 2 hours, then I have to pour the concrete, that's an hour, and then I have to let it cure, that takes 2 days. But that's not part of estimate activity durations. It's part of our next process, develop schedule. And we look at these things as separate processes here in the PM Prepcast and in the PMBOK guide, because we have different tools and techniques that we apply in each of the processes. We also have different skills that are required of us as project managers as we execute these processes. That's why this is presented to you as separate processes and separate activities, and not as one big blob. Let's review. In the estimate activity durations process, you take your schedule activities and all of your influencing factors, and you ask your specialist one single question. How long does this activity take? You use expert judgment, perhaps by using group decision-making or one of the 3 estimating techniques, either analogous estimating, parametric estimating, or 3-point estimating, to give you a duration for each activity. Next, you need to perform a reserve analysis so that you can then decide to add in certain time buffers on top of the original duration estimate. You will document these estimates as well as other information in the activity attributes and other pertinent project documents. And, very important, state the duration estimates as a range, such as it takes 3 weeks plus minus 10% to finish the preliminary design. Also, do not forget the 3-point estimating formulas. We have the one here for triangular distribution, where you simply take each of your estimates, your optimistic, your most likely, and your pessimistic, you add them up and then you divide them by 3. Or we have the beta distribution formula, where we give more weight to the most likely. We take the optimistic, add 4 times the most likely, and 1 time the pessimistic, and then we divide the whole thing by 6. And by the way, the formulas, the way they are written here, they come straight from the PMBOK guide there, with the little lower caps T in front of each of these letters. It's much easier, frankly, if you just remove that lower caps T and you look at them in this way here. Your estimate is optimistic plus most likely plus pessimistic divided by 3, or for the beta distribution, your estimate is optimistic plus 4 times most likely plus pessimistic divided by 6. So for simplicity's sake and to make it easier on your PMP exam, do remember the formulas here in this way without the lower caps T. So much simpler. So what type of questions do we see in sample tests online or in books? Well, a favorite question target are, of course, the 3 estimation techniques that we have just looked at. So, which of the following is not a technique for estimating activity durations? Is it A, analogous estimating, B, parametric estimating, C, the 3-point estimating, or is it D, bottom-up estimating? I'll give you a couple of seconds here to think about this one. The correct answer is, of course, D, bottom-up estimating is not a technique for the estimating of activity durations. However, make a mental note that bottom-up estimating, even though it is exactly what we are doing in this process, analogous estimating, parametric estimating, 3-point estimates, you usually go to every single task and you estimate those. So you're doing bottom-up estimating per definition. However, bottom-up estimating as a technique is not specifically mentioned in the PMBOK guide. You will also find a number of questions that are going to come up in terms of duration, resources, and their level of productivity. And the answer to this type of question is very dependent on the context of the questions and the parameters that are given to you. For example, what is the duration of a 20-hour activity that has 2 resources assigned which are 100% productive? The answer is, of course, that 20 hours performed by 2 resources that are 100% productive, well, it takes you half that time. It's 10 hours. Each of your resources needs to work for 10 hours, and then you have your 20-hour activity. But what if we assume that they're only 50% productive? Well, the answer means, of course, it will take them 20 hours in total. You need to be prepared to take these kind of parameters into account when it comes to estimating durations. You need to be thinking through them and calculating them correctly. And you also have to be aware of possible trick questions like this one here. What is the duration of a 20-hour activity that has 2 resources assigned that are 100% productive and are willing to work 2 hours of overtime? Well, the answer is that it would still take them 10 hours, just like before, because the 2 hours of overtime have nothing to do with the duration. It takes 10 hours of actual time of duration, no matter if that time is expended during your regular work hours or at night as overtime. So in order to answer all of these question types and styles, you have to understand the differences among the concept of effort, duration, and elapsed time, the difference between contingency and management reserve, and you should definitely know the 3 estimation techniques, the differences in methods and accuracy among them, and any related formulas and calculations. And this concludes our look at the estimate activity durations process. So Justine and I are going to have a cup of tea.
I'll be back.
Until next time.